आज हम स्टार्ट करने वाले हैं इलेक्ट्रिक फील्ड एंड पोटेंशियल ड्यू टू एन ऑसिलेटिंग डाइपोल. ओके, सो what's the electric field, what's the potential due to a general dipole? You all know, like we calculated, like in for dipole the potential is kp cos theta upon r square, and the field also we can calculate something like kp for r cube into 2 cos theta into r cap plus sin theta into theta cap, something like this. We calculated electric field also and potential. But now at here we will calculate the basically, and we will calculate the electric field and potential due to for an oscillating dipole. So you should understand first what is the oscillating dipole here. So the term oscillating dipole. So let's understand this term. So first of all, the dipole which accelerates, okay, accelerate or deaccelerate, okay, जो एक्सेलरेट करे या डीएक्सेलरेट करे उस डाइपोल को हम क्या बोलते हैं, ऑसिलेटिंग डाइपोल. तो ठीक है, फर्स्ट थिंग तो ये हो गया कि वो डाइपोल एक्सेलरेट करेगा या डीएक्सेलरेशन करेगा. सेकंड थिंग क्या होगा, वो आपका ईएम वेव, क्योंकि एक्सेलरेट करेगा तो क्या जनरेट करेगा, ईएम वेव जनरेट करेगा. ओके, तो उसे हम क्या बोल देते हैं, ऑसिलेटिंग डाइपोल. Now we are calculating the first of all, they're like saying that what is the potential charge form, because dipole has two charges, q plus and q minus and some distance t. So we are saying what is the form of charge here, because I am saying the charge is containing the accelerating or deaccelerating term. Okay, so q is form of q naught sine or cos. Okay, q naught sine omega t or q naught cos omega t. You can say anything of it. So this is the form basically, and we can say this is the charge form. So for the dipole, we are taking this one, okay, the cos term. So the what's the dipole here? So dipole term will be like p naught cos omega t, because that's the same thing. Now p is what, the charge magnitude into the distance between the charges. So this is like magnitude of the dipole, and this is the cos term which is coming from oscillating charge. Okay, so let me go again. I'll go ahead. So देखिएगा, सबसे पहले आप जैसे मैंने बोला डाइपोल मोमेंट का जो आपका मैग्नीट्यूड है वो कितना होगा, तो आप पता है तो चार्ज का मैग्नीट्यूड इनटू द डिस्टेंस बिटवीन देम. वी आर टेकिंग द डिस्टेंस इज t. Okay, so we are now proceeding. Potential is generally kq by r for a general charge. Okay, but here the charges are 2, q plus and q minus. So what is the potential? So we will say that kq plus upon r plus minus kq minus upon r minus, because q minus is negative charge, and this is positive charge. Okay, this is the like a complicated topic of the MSc, but we will see in easy form. Okay, so first of all I am taking the charges here. Again I am drawing the perfect diagram, plus q minus q, and here some p point, here we have to calculate the dipole. Okay, this is r minus, this is r plus, in the middle we are saying this is r. Okay, this is d by 2, this is d by t. So now we are saying the q plus is like the form is q cos omega t. We see now, we pause on some time, so we are putting the values here. So k q naught into q plus is q naught, we have taken the magnitude outside, cos omega. Now t minus, because we have omega t at general, but we are saying r plus and r minus, so it will become q t minus r plus upon c divided by r plus minus cos of omega t minus r minus over c divided by r minus. Okay, this is now the potential ड्यू टू ए डाइपोल. लाइक जनरल फॉर्म हमने लिख दिया, अब इसे हम सोल्व करेंगे. ठीक है, सो आपको पता है लाइक ये डायग्राम आपको तो दिख रहा है, इस डायग्राम से आप जब आर प्लस और आर माइनस का रिलेशन निकालेंगे तो आपको मिलेगा कि आर प्लस और माइनस में दोनों साथ ही लिख देता हूँ, आर इंटू 1 प्लस माइनस डी बाय आर जो मिडल डिस्टेंस है इंटू कोस थीटा प्लस डी बार 2r का होल स्क्वायर की पावर 1/2. ओके, This is the form we had. Now we are saying we want 1 upon r plus and 1 upon r minus also. This is the here we put this value and 1 upon r plus and 1 upon r minus we are having. So let's see this thing. So we are assuming the dipole and between the charges rho t distance or d distance is very small. Okay, d is comparable to r, very small. So this is approximation. So from that we can say r plus and minus is basically r into 1 minus d upon r cos theta to the power 118. Okay, so and we are saying when the d is less than r, then d upon 2r term will be 0. Okay, basically, so this will come out here. Now 1 upon r plus minus part will become 1 upon r, and this will be minus 1 by 2. So we are like 1 plus x to the power minus 1 by 2. What will be that? 1 minus 1 by 2 equals something to. We are doing the same thing there. So binomial expansion 1 minus d by 2r cos theta. This is the value of 1 upon r plus and 1 upon r minus. Okay, there should be plus 4 plus and minus 4 minus. Okay, so we'll put this value here in the potential term equation. We are given this equation first. Okay, now coming back to our next thing, we have calculated basically potential. Okay, so we are writing potential and we are writing the potential term. So q naught and over 4 pi epsilon naught, we are taking the comma, and there cos omega inside t minus where the r minus value and r plus value. Okay, here the r plus value come, so t minus 1 upon c r into 1 minus d by 2r cos theta. Okay, and upon r plus. So you can see what I done here is the this one r plus. So r plus upon c, there is r plus upon c. So we are putting the value of r plus here. That is r into 1 minus d by 2r cos theta. Simply, okay. We are not doing any hard calculation. So this is now minus cos of omega t minus r into 1 plus d by 2r cos theta, and here the form r minus. Very simple. Now we are solving, like we have 1 upon r plus 1 upon r minus, both values we had. So what we will do now, we will put the value. Okay, so if we do, so we are putting the values, and after putting the values, we are getting cos of omega. Okay, first of all, we are writing the charge term over here for q naught upon 4 pi epsilon naught. Now cos omega t minus r upon c cos omega d by 2c cos of theta inside plus sine of omega t minus r by c into sine of omega d by 2c cos of theta. So here what we have done, this is equation second we are calling. Okay, 1 upon r term we have taken outside, so this is 1 upon r. Now we are we are putting the formula of cos a plus b, cos a minus b. Very simple, like you know now, cos a plus b. What will be that? This will be cos a cos b minus sine a sine b. Very simple. Okay. Now we are saying that here in question 2, we are approximating the omega by c greater than 1 by r. So we are saying that r is greater than lambda. Okay, or we can say lambda is means c upon omega. So what will be this? There some terms are should be approximated. So omega by c is greater than 1 by r. So which term we can see to the final reduction? This expression will be reduced to v is minus u upon 4 pi epsilon dot r 1 minus d. Okay, we are approximating it. Here, wait 1 second. This one. So I am writing the final expression. Okay, I am writing the final expression after approximating it from this equation. Okay, so it will become minus 1 by 4 pi epsilon naught r into this will become omega d by 2c directly. Okay, we are approximated now this one, omega d by 2c and this will become cos theta and sine of omega t minus r upon c into 2 minus d upon 2r cos theta into 2 cos omega t minus r by c. You can also solve this calculation by yourself, okay? So you will get a better understanding. So this will become, we are taking the outside qd cos theta divided by 4 pi epsilon naught r into minus omega by c sine omega t minus r upon c. So this is the required potential form we are getting from the approximation. Okay. So now, what is the next procedure to find the electric field? Our first task है, हमारे पास task था कि इलेक्ट्रिक फील्ड के लिए जो रिक्वायर्ड होता है क्या होता है माइनस डेल ऑफ वी माइनस डेल इन अपॉन डेल टी. So we have converted the first term potential. We'll put here, but we have note the A vector. What is the A vector here? A vector is basically vector potential. Okay, vector potential basically vector potential. So now, for finding the vector potential, we have to calculate the I current. Okay, so current is simply dq over dt. Q is a function of t, no? Q is q naught omega, q naught cos omega t. So it will become minus q naught sine omega t into omega. Omega is the derivation. When we will do the derivative of cos omega t, it will give minus omega sine omega t. Very simple. So okay, what is the A vector form now? A vector is mu naught over 4 pi I into di prime over r. Okay. So what you will do next? You have the value of vector d and I value will be here. So we'll put the I value and we are doing the integration from minus d by 2 to plus d by 2. So it will come out mu naught over 4 pi and minus q naught omega sine omega t prime divided by r into integration of dl prime. And okay, so it will be come out. The dl prime integration is should be in it. We can say this will be minus d by 2. We'll take plus d by 2 and minus plus d by 2. It will come out. Okay, so final cover dl minus mu naught upon 4 pi q naught d omega by r sine of omega t minus r on c into z direction yes in the A vector. Okay, so A vector is basically minus mu naught upon 4 pi. We can say what is the q into d? Is it the p naught? No, isn't the p naught? So we can put here p naught omega by r. This should be sine omega t minus r upon c into z direction. So in very basic form we have vectored the vector potential also. Okay, so this is the vector potential. So till now you can see we have calculated two things. First is vector potential and the other is the potential. Okay, so from now we can say the electric field will be minus of conducting and like 1 second. This will become minus of del E minus del A over del T. So now we will put the value of potential and vector potential and do the calculation and we can get the electric field. So we will calculate this in next lecture. Okay, calculate this in next lecture. So